Hello and welcome to this lecture. Now we're going to go behind the scenes of what happens when we send a request to index a document or query the document in Elasticsearch. So as you're aware, I spoke about this in the first lesson, I think, that Elasticsearch is a distributed technology, meaning that, I have Elasticsearch running on this laptop. If I had another laptop sitting besides it and I installed Elasticsearch on that, and if they were on the same network, both of those laptops could communicate with one another. And if they're both, if they have Elasticsearch running on them, Elasticsearch could be communicating with the other instance. And together it would form a cluster. And this could be an unlimited number of computers talking with one another to form a large Elasticsearch cluster. And what is the purpose of having a cluster, right? Why not just have it on one machine? Well, one machine can only do so much. But if you distribute the problem amongst many computers, right? Or many nodes, this is a technical term for a computer. If you split the problem amongst many nodes, then, of course, it's faster to solve the given problem. So if we have a really large search problem and we break it up into really, really small ones and we hand them out to each one of those computers, and all those computers can sort of work in parallel to solve the problem in a much shorter period of time as opposed to just one computer. So, having said that, we need to talk a little bit more about the index. Now, in the previous lesson, I showed you that we can create an index, for example, vehicles or, the business index. And if you look at the schema, right, the index structure, in the settings section, you'll see that there are some fields. For example, the number of shards and the number of replicas. And those fields should be a hint for you that the underlying structure for the index is not really what meets the eye, right? When we interact with Elasticsearch, 99.9% of the time, we're going to be dealing with this index structure. For example, let's call it vehicles, right? We have this vehicles index. I'm just going to sort of draw out a box. And let's just say it has many, many documents in it, right? Let's just say there's 100 documents in this index. So we can have, obviously, billions of documents in an index. Elasticsearch is actually very scalable. But for this example, let's just say we have a vehicles index with just 100 documents. This is actually just a logical representation for the user like you and I to work with vehicles data, right? This is a logical representation. But under the hood, the physical representation of this is actually something called shards, okay, on the disk. So a particular index like this could be split up into multiple shards. So if we define an index with two shards, let's say we define a vehicles index with two shards, storage would be split up into two shards. So let me just draw that out here. This is going to be shard 0 and this is going to be shard 1. And shard 0 could contain data from document 1 to 50, and shard 1 could contain data for documents 51 through 100. Okay? So all the documents are split up into these two shards. So why shards? Well, the reason is if we have, let's say we have two nodes, right? Two computers running Elasticsearch. Let me draw those two nodes out here, right? We have node 1 and we have node 2. Sorry for my drawing skills. So node 1 is one computer and node 2 is another computer, and both of them have Elasticsearch running, and they can, of course, communicate with one another. They're on the same network. So how would we split this vehicles index onto two nodes, right? That doesn't make, we can't really do that unless we have a smaller unit of storage. And that's actually this thing called shards. So we can have, for the vehicles, we can have shard 0 be on node 1, right? And I'll just call it P1 for now, P0 for now. And I'll explain to you why I call it P. And for node 2, we can have P1, okay? So 0 shard is on node 1 and the shard with the ID 1 is right here on node 2. So the P represents primary shard. So these are primary shards, but it would be helpful to have a backup of these shards, okay? Because these are the actual containers of the data. We better have backups for these guys. So there's something called replica shards, and that's also a configuration setting that you can set when you're creating your index. So a replica would basically be an exact copy of 1 through 550 documents. We can call this R0. Okay, and it'll contain the same exact documents as the primary shard. We need the same thing for the second set of data from 51 to 100. These are going to be also made copies of, and we'll put it into R1. So replica 0, replica 1, and replica 1 could be in node 1, so we'll call it R1, and replica 0 could be in node 2, so we'll call it R0 for node in the second node. All right, so the primary, this is the actual primary shard, and its replica is on another node right here. And this node 2 contains a primary shard 1, but its replica is on the other node in node 1. So notice how the data is distributed in Elasticsearch amongst these two nodes. If we didn't have replicas and we only had one node, we would have a problem. Both shards would be on the same node, and if that node goes down, we would be in trouble, right? We would be out of data. And similarly, if we had two nodes and we don't have any replicas, one shard is on one node and the other shard is on the other node, that doesn't do us any good either, because if we lose one of those nodes, we lose half of our data. So replication of data is very important. And this is just an example with two nodes, but we can have 5 nodes, 10 nodes, 20 nodes, depending on the amount of data that we anticipate in our cluster. Now, the machine that I have here that I'm recording these lectures on, this is just one machine, and it has a single instance of Elasticsearch. So you can think of this as just one node. And it doesn't matter how many replicas we create of any indices, it's just one node. Okay, and if it goes down, we lose all of our data. So since this is not real, production level data, it's just, I'm just making this data on the fly. I could care less about this node going down. But in a production environment, you want to make sure you prioritize high availability. Make sure you have enough replicas and enough nodes to distribute the data in your cluster. In this case, if node 1 goes down, node 2 still has the shard 1 as well as shard 0. So it has all the data. And you can think of these guys, I'm just going to draw a cloud around it, because you could think of these guys as the cluster. Okay, this is the cluster of nodes that make up Elasticsearch. Now you can have many, many nodes like this all in one Elasticsearch cluster. But for this example, we're only showing 2 nodes. Now it's important to understand that we can send our requests to any one of these nodes, any node on the cluster, right? Every node on the cluster is fully capable of serving any kind of request, whether we index data or whether we're querying data, it's capable of serving those requests. The reason for this is because every node knows the location of every document in the cluster. And so it can forward the requests directly to the required node if it doesn't have the data that the client may be searching for. So let's talk about what happens when we send a request to this cluster. I'm going to clear the screen here and draw the node 1 and 2 again in a slightly neater fashion, hopefully. All right, so here we are. I redrew the node 1 and node 2. Node 1 contains the primary for shard 1, and node 2 contains the primary for shard 0. And again, what are these shards? These are the splits of one of the indices, right? So let's say we have a vehicles index. I'm just going to draw that out here. This is a logical representation, but on the disk, the data is managed in shards. And for this vehicles index example, we decided that we want this index to be split up into 2 shards, shard 0 and shard 1. Okay, so the 0th shard contains data from IDs 1 through 50, right? These are the document IDs. And shard 1 contains data from documents 50 to 100, right? Provided that we have, 100 IDs in this example, 100 documents. So let's say the client will say that, this is the client, users like you and I, that need to interact with Elasticsearch. Let's say we send an index request to index a particular document. We send it to node 2, an index request. What node 2 is going to do is take the ID of this document that we are trying to index, and it's going to run it through something called a hashing function. Not important to go over the details of that hashing algorithm. You can look that up on your own. But basically, because of running that hash function, it's able to determine, based on the ID that we're passing in, where that particular document needs to go. And so if the document needs to go to first shard, which is right here, the primary shard. Where's 1P? 1P is right here in node 1. The request was sent to node 2. So what node 2 is going to do, it's able to figure out exactly where to send the document to because of this hashing function and the ID that we passed as part of the document. So what it's going to do is going to reroute that request over to the particular shard, right, in node 1. And so we would be able to successfully index into 1P. But remember that we also have a replica of this 1P, and that's this 1R. So after the indexing is successful in 1P, what this is going to do is going to replicate. So it's going to send the request again to this guy right here, 1R, so that both shards, the primary as well as the replica for 1 has the same data. And if there were other nodes, let's say node 3 and 4, once it's successful on the primary shard, it will send to all the other nodes where the replicas may exist, so that all of the shards that are replicas are in sync with the primary shard. Okay? Now let's say instead of index, let me just erase this. Let's say instead of an index request, a delete request is sent. And again, excuse my handwriting. Let's say this is a delete request executed by the client. Again, every node knows where all the documents are in the cluster, right? So if the request is sent to node 2, and this document that the client is trying to delete belongs in shard 1, it's going to send it first. It's going to send that delete request to the primary shard 1 first. Once that deletes the document, then a request will be sent to the replica, which is in node 2, to also eliminate that document. All right, so it's very, very similar to how index works. It's just a different kind of request. All right, so we spoke about indexing and deleting, which work almost identical, right? And again, I'm reviewing that the vehicle's index is split up into these shards. These are the actual containers of data. The vehicle's index overall is a logical representation of the data, but it's actually split up into shard 0 and shard 1, and shard 1 primary is on node 1, and shard 0 right here, primary, is on node 2, and the replicas are on the other nodes, right? We can't have the replica as well as the primary on the same node, because if that node goes down, we lose that entire shard. So it's best to split the shards like this because it allows for higher availability. So we spoke about indexing, we spoke about deleting. Let's talk about the GET request. When we get a particular document, we specify the ID. We send that request to node 2. Node 2 is going to know exactly where that document exists in the cluster. Every single node knows where every single document is amongst the cluster because we're sending an ID. And using that hashing function that I spoke about earlier, it runs that hash function on the ID to determine where the document may be on the cluster. So it sends that request over to that particular node. Now for read requests, like this is a read request, the coordinating node will choose a different shard copy on every request in order to balance the load. All right, so it may return the results from node 2, right? Because node 2 contains all the documents, so does node 1. And let's say we're looking for ID 17, right? 17 should exist in shard 0. So this is the primary shard 0, and shard 0 also exists on node 1, but that's the replica. Because Elasticsearch load balances requests, especially for reads, right? Reads need to be extremely fast. So it may or may not go to node 2 to give the data, all right? Because the ID 17 exists in shard 0. So node 2 contains the primary shard 0, but it can also route the request to node 1, which contains the replica for shard 0. So it may forward the request to node 1, or it may return the data from node 2, because both of these nodes have the same data for shard 0. So this request is going to go here, and the result is going to be sent back to the client. And the very next read request may be for, ID 18, document 18. That may be sent to node 1. All right, and then the following request for document 19, reading document 19, that may be sent to node 2, and it's just going to flip back and forth between these load balancing read requests, okay? And this process is called round robining. In networking, round robin means go in a particular order over a certain set of nodes rather than hammering one of the nodes only. So if we had 10 nodes, a GET request may hit one of the nodes, and then the very next request may move to node 2, and then node 3, and node 4, and all the way down to node 10, going back to node 1, and that in some particular order, rather than hammering just one node only. An Elasticsearch index is a logical representation of the data, as I explained. So the physical containers of data is actually shards, and that's how an index could be split amongst a cluster of nodes, right? Each node contains part of the data of the index. And this part of data that we're talking about is the shard. So an index is broken up into multiple physical shards. Those are the real containers of data. So what is each one of these shards? Well, a shard is basically a Lucene index, okay? And not important to know the details of what Lucene is, but basically it's a search library that was introduced back in 1999, and Elasticsearch just makes Lucene distributed, right? That's all it really does. Now, of course, there's a lot more to it, but the searching power all comes from the shards, which are Lucene indices. So let's go a little deeper into what is a shard. So I'm just going to draw a shard out here. A shard is a container, physical container of data, and what exactly does that mean? Well, we have something called segments. All right, I'm just going to draw that out here. A segment belongs inside of shards. All right, and a shard can have multiple segments. And each one of these segments are inverted indices. And I explained to you what an inverted index is a couple of lessons ago. So each one of these segments, right, this is a segment. Each one of these segments is an inverted index. I'll just call it ID. IDX, right? An inverted index. So what does that mean? Well, I'll give you a quick recap about what an inverted index is. If we wanted to build a full text search capability for all of the plays Shakespeare ever wrote, we'd need to gather every single document, right? And take each one of those words from that document and sort that long list of words in alphabetical order. And next to each word, we need to put the document that word occurred in, and not only that, the actual location for that. So this is an inverted index. I'm just going to really quickly, this is the token, we can call it token, which means just words. Let's just say this word starts with A, this word starts with B, and this word starts with C. And I don't feel like coming up with words here, but think of these as words. If this word occurs in documents 1, 2, 7, 15, or whatever, and so on, when we need to search for this particular term, we can very quickly figure out that this term exists in these documents. And these documents could be, thrown at us, and we'll be able to see what is the data that surrounds this word. So the segment, each segment is a setup like this. It's an inverted index. Now you can imagine all of the words in Shakespeare vocabulary. That could be a long list of words. Luckily, we have these things called segments. The data could be broken up into multiple inverted indices, and a shard contains multiple segments. And as you're aware, an Elasticsearch index is made up of multiple shards. And that is how an index can span multiple nodes, because the unit of separation is the shard. So let's say we have node A and node B, right? We can have an index be split amongst both of these nodes, right? Shard 1 and shard 0 or whatever could be split amongst both of these nodes, and together it makes up an index, right? So a shard is basically a container of inverted indices, also called segments. So when we're actually indexing data, let me make some room here, let's move up. I want to talk a little bit about indexing and how what to expect when indexing takes place. Indexing is the slowest process in any search engine, right? When you go to Google, you type in some words, it quickly is able to retrieve those web pages that match your search criteria. But that seems fast, but it must have taken Google a lot longer to index that data into their search engine compared to, just retrieving it when you're looking for that information. So Elasticsearch works in a similar way. indexing data into Elasticsearch takes a long time. And the reason for this is because Elasticsearch needs to prepare the data that you give it. It needs to prepare that data and run it through this process called analysis. And we'll go into great detail in the next lesson about what analysis is. But basically, that's a process of taking raw text and converting it and turning it into an inverted index so that the data is searchable. So that process of converting your text into an inverted index takes a long time, right? So if, let's say, Shakespeare wrote so many plays, if we needed to take all of those words that he ever wrote and we store them into a search engine like Elasticsearch, that's a time-consuming process because we need to create an inverted index, right? Elasticsearch does this for us. Elasticsearch formulates an inverted index, but it takes time for it to do so. Once it's done doing that, of course, the searching is very fast. So I want to go over what exactly is meant by indexing. What is that process all about? So as you're aware, we have shards, right? And shards are, they're basically pieces of an Elasticsearch index. An Elasticsearch index is made up of multiple shards. And a shard has these things called segments, which I described to you, right? And what are these segments? These segments are nothing but inverted indices, right? Each one of these are inverted indexes. To form each one of these segments takes some time. Let's say we send a JSON document. I'm just going to draw a document like this. Hopefully that looks like something like a document, but we send some data to Elasticsearch, right? And what Elasticsearch is going to do is going to take that document and split all of the different words, going to tokenize them, get rid of any extraneous suffixes and prefixes of the words, and just try to get to the root of those words, eliminate all of the white space, and just, basically prepare the data. And that process, it's called analysis. And we'll get into great detail of what analysis is in the next lesson. But basically, analysis is the process of converting text, such as emails or, even text in long books, Shakespeare plays or different blogs, all that data. It's the process of taking all that text and converting it into something called tokens or terms. And we'll go into exactly how that works in the next lesson when we talk about analysis. But that's basically the step that's required to feed the inverted index. So it takes all those words and it creates an inverted index out of them. And you saw what the inverted index looks like, right? We went over this a couple of times. So once it forms a structure like this with the words in that document that we sent to Elasticsearch, once it forms this inverted index, then it gets sent to this thing called a buffer, a memory buffer. All right, so there's one document, we sent it to Elasticsearch for indexing. It went through the analysis step, an inverted index is created. Then this document is sent to this thing called a buffer, and the buffer gets populated with that document. Then we send another document to Elasticsearch, goes through the analysis process, an inverted index is formed, and it sends it into the buffer. Once this buffer gets filled up, then this buffer gets committed to a segment, okay? And that's how segments are formed. So then, this segment is formed up to this point. Then we send another document, and this buffer clears up. Once the buffer gets flushed or committed to a segment, the buffer has enough room to accept the next set of documents. So we send more and more documents, and buffers get filled up like this, and then they get committed to the segment, and then segments get populated like this. Once the segment is completed, this segment is now an immutable inverted index. Okay, you can't change this segment, right? This is now an immutable inverted index. I'll call it IDX for inverted index. All right, once this segment is completed, it moves to the next segment, and that's how basically shards are formulated. They're made up of these immutable inverted indices called segments. You can create more segments, but you can't overwrite existing segments. They're immutable. You can't change them. And this is the basis of setting your data so that it's searchable. So this shard now, once the segments are done, this shard is now searchable, right? It's searchable, and you can rest assured that the data in here is not going to be changed. It's been processed through analysis. Inverted indices were formed, and then they were committed to the segment. So this is permanent data that you can search, and that's how each one of those shards are formed. So the magical process that happens here is this analysis step. Okay, that's what turns a document like this into an inverted index. So we're going to go into more detail of the analysis step in the next lesson. So I'm going to wrap up this lesson. We covered a lot of ground. This is one of those lectures that you might want to revisit later on in the course, just to get a refresher on these underlying fundamental components of Elasticsearch, right? We talked about distributed execution of requests, how different nodes handle the request, and what happens behind the scenes when documents are indexed. So we're going to go into greater detail on the analysis process of how these words and large text get tokenized and split up and put into the inverted index. We're going to go into greater detail about that process in the next lesson. So stay tuned. I'll see you soon.